Alright guys, can you do question 1 dice now? Okay, man. Alright guys, let me show you how to do. I'm sure many of you have already done question 1. So you have an x coming from a binomial distribution with parameters n and p, and we have an estimate for p hat is defined by x divided by x by n. So this is the estimator for p, and we want to find the variance, the bias, and the MSC. Right. So, all right. The first thing is bias, guys. The bias of p hat, as you know by definition, remember this is the definition of bias. The expectation minus the parameter you're trying to estimate, right? So this will be yes. Now, all of you guys know that the expectation of a binomial variable with parameters n and p is n times p. Yeah. So this is, so the bias is equal to 0. Yeah. So what it means is that p hat is unbiased. Excuse me, guys. I have a bad flu. Don't come close to me, okay? So p hat is an unbiased estimator for p. Right. The next thing to do is to find the MSC. Now, the MSC of p hat, because the estimator is unbiased, MSC is the same as the variance of p hat. Okay. And this is the same as this. Okay, now taking the n outside, remember when you take a constant outside, it becomes 1 over n squared times the variance of x. Now you guys know that the variance of a binomial variable is n, which is this, and this, as n approaches infinity, approaches 0. So the conclusion is that p hat, the estimator p hat, is unbiased and consistent. All right, is it clear to you guys? Is that clear to you, all of you? Any questions? All right. All right, sir. Yeah. Okay. Can you do question 2 now, please? Done question 2, guys? Each xi is normal, mean 0. From the xi is normal variable, mean 0 and variance. So the expectation of xi squared is the same as the variance of xi. All right, guys, can we look at question 2, guys, now? So you're given xi you're given these observations, right? And you're given the estimator that 1 over n this is an estimator for this is an estimator for sigma squared, and you're asked to find the bias and the MSC. Now, as you know, in mathematics you can do any questions in multiple ways, so I'm going to show you a way to do it different from the solutions I have written down. Now what I'm going to do is, let me call this T, right? Now T, you can write it like this is I, okay? You see what I've done here? I have divided xi by sigma, and there's a square outside, so you need to multiply by sigma squared. The reason I'm doing this will become clear in a minute, because right? Okay. Now, you should look at this, guys. You should look at page. Excuse me. Sorry. You should look at page 17, equation 75. Right? You will see that this has the chi-square distribution with n degree of freedom. That's mainly equation 75 on page 17 of the lecture notes. Okay. So I'm going to use this fact because to make things easier. So to find the bias of T, okay, so which is okay. Now we know that, you may remember from last week tutorials last week, that the expectation of a chi-squared variable with n degrees of freedom is equal to n. It's by page 16 of the notes, right? So this is equal to 0. So the bias of the estimator is equal to, excuse me, is equal to 0 because I have used the property from page 16 of the notes that the expectation of a chi-squared variable is equal to the degree of freedom. Now to find the variance of T, which is the same as MSC because the bias is 0, okay, so this is going to be now variance of a chi-squared variable with n degree of freedom is 2 times n. That's by page, once again by page 17. You should look at page 17 of the notes. You will see a formula which says that the variance of a chi-squared variable is 2 times the degree of freedom. So in this case is 2 times n. So this will be n, which approaches 0 as n approaches infinity. So the conclusion is that T is an unbiased and consistent estimator for sigma squared. Okay. Is that clear, guys? I mean, this is only one way to do it. I'm sure there are other ways. Like if you look at the solutions, I have used a different way to do it. But this, I think this is the easiest possible way to do it, because we're using the non-result. Any questions, guys, please? No, sir. Has everybody signed this attendance sheet? Can you, if this is okay, can you do the next question 3, please? If this is not okay, ask me questions. Can you see, sorry, this should say var, this should say bias, okay? Hopefully now you can see better. You guys do question 3, please, now. Are you okay with this, guys, or no? Any questions on this? Okay. You guys sign over here, guys. Anybody hasn't signed? You done question 3, guys? Alright, let me show you how to do, if you haven't done it. So this is question 3. Now, you are given a parametric distribution, right, f of x, and the first part is to show that x bar is a biased estimator for delta. So what do you need to show, guys? You need to find the bias of x bar and show that it's not equal to 0, right? Bias means that this is not equal to 0. This is, so by definition, this is this minus this. Yeah. Now, any ideas on how you can find the expectation of xi? How how do you find expectation of xi? Hmm? What do you need to do, guys? Hmm? You need to integrate the density from delta to infinity of x e, let me, delta minus x, delta minus x dx, right, minus delta. Any ideas on how you can work this integral out? You must be experts in integration by now. Better than me, I guess. What do you need to do integrate this, guys? Do a substitution. Say y equal to x minus delta. So x equal to y plus delta. Okay, I'm gonna make this. Okay, guys. Now the limits of integration under this will go from 0 to infinity. X will become y plus delta, and this will become e of minus y dy. Yes? Okay, now things are not so difficult, because what you have here is 1 over n Yeah. Now you should know what these integrals are, guys. Do you guys remember what something known as the gamma function? What's this integral equal to, guys? Quickly. Come on. What's this integral equal to? Huh? It's the gamma function at, and this integral here equal to? Do you see this or not? You forgot in the definition of gamma function I talked about a couple of weeks ago or so. You should remember at least for the duration of this course. After that you can forget about it if you want. Only kidding. So now gamma 2 is 1 minus. Remember, gamma at n is n minus 1 factorial. So gamma 2 is 1, gamma 1 is 0 factorial, which is, and this is 1 plus delta minus delta, which is 1, which is not equal to 0. So x bar is a biased x bar is a biased estimator of delta. Is this clear or not? Guys, are you okay? Yes or no? Alright, that's only the first part. The second part of the same question is, hence find a linear transformation of x bar which will provide an unbiased estimate of delta. Alright, what do you think it will be? So we know that x bar is a biased estimate of delta. So how do you make this into an unbiased estimate? I think I talked about this last week. What you do is you define a new estimator say y equal to x bar minus 1, right? And this new estimator will be unbiased for delta, because this is unbiased for delta, because the bias of y, which is the expectation of y minus delta, which is the expectation of x bar minus 1 minus delta, which is the expectation of x bar minus 1 minus delta. We know this is delta plus 1. Alright, so hence the new estimator, which I called y, has bias equal to 0, right? And hence it is an unbiased, estimator for delta. Well, that's the second part. Now the third part, the same question: is your new estimator consistent for delta? All right. To do that, to find consistency, you need to find the variance, right? So that's what I'm going to do now. Let's try to find the variance of the new. Are you guys okay with this? Yes, sir. Yeah, okay. So I'm going to find the MSC of the new estimator, which is the variance of the new estimator, because y is unbiased, which is variance of x bar minus 1, which is variance of x bar yeah. Stop me if you don't understand anything, just stop, okay? Ask me to stop. Alright, this is what you get. Now the variance of xi okay, now you should go back to the previous slide that I had over here, guys. You probably remember that. Excuse me. You probably remember that. Sorry. Oh. This is 1 plus delta squared. Okay, this is from what the calculations we did earlier. The expectation of xi is equal to this. All right. Now, you should do the similar calculations for this guy here. You get this, and you should do the same substitution, that is y equal to x minus delta. You should make the same substitution as before, guys. You will get I know it's calculation appear lengthy, but once you get used to this, you can do it in a minute. Yeah. Now, because I'm running out of time, I'm gonna like do a shortcut here. This, after you expand this, guys, and simplify this, guys, we get gamma of 3 plus 2 delta gamma of 2 plus delta squared gamma of 1 minus 1 plus delta squared. This is what you will get, right? And if you simplify this, guys, you get, if you simplify this, unless I made some errors, this will be equal to 1 over n. Correct me if I'm wrong, but this is if you simplify this, guys, this is what you will get, I think. And this approaches 0 as n approaches infinity. So the conclusion is that y is unbiased and consistent. All right. I skipped a few steps because of the time, guys. But is that clear or not? Can you try the next, guys? Next question, guys. Anybody who hasn't signed it yet? Question 4. All right. Lambda, the estimator for lambda in the Poisson distribution, ML estimator, is x bar. So the expectation of, we know that the expectation for a Poisson variable, you guys remember from your first year, I guess, is lambda, and this is lambda minus lambda. So the bias is 0. It's trivial, right? Now to find the MSC, guys, to find the MSC of lambda, remember MSC is the same as the variance with bias is 0. So this is variance of 1 over n times the sum of xi, which is 1 over n squared times the sum of the variance of xi the variance of a Poisson variable is lambda. So what you have here is lambda by n, and this approaches 0 as n approaches infinity. So hence lambda is unbiased and consistent. Now the three remaining questions in this problem sheet are for next week, right? So if you haven't done that, just don't worry. I will do these questions 5, 6, and 7. I will do them next week, right? Question 5, question 6, question 7. All right? All right, guys. I'll see you guys in a sec. Bye bye.